class, and welcome back to another video. So today we are going to look at polymers. And remember when we made slime in the classroom, we talked about the principle behind making slime and linking up all these little chains of small molecules into a long chain, and that long chain is called a polymer. So, things that you need to remember, the short little sequences or stuff that we've got, the building blocks, are called monomers. And at level 2, we're only looking at these building blocks with double bonds. Because remember, we looked at alkenes, and alkenes are unsaturated. So remember that double bond can open up and grab onto anything that I feed them, including themselves. So if I feed them a lot of monomers, a lot of the same things, what they'll do is they'll open up bonds and arms and hook onto it to make a long chain. So the problem is, sometimes the chains aren't just made up of 2 carbons. Sometimes it's a longer chain, and sometimes these extra little bits of the chain gets in the way. So what we need to do when we write them down, and remember those atoms can move, so when we write them down in a 2-dimensional thing, or 1-dimensional paper, it is quite hard to actually visualize what's happening. So I'm going to quickly just hopefully show you a shortcut or an easy way to remember it, just to make any molecule that they give you easier to write down as a polymer. So what we have here is we've got 2 monomers, and these monomers are called, we've got 3 carbons, so it's a prop. So prop 1N and another prop 1N, and they are linked together with double bonds. So, in theory, when we look at this polymerization reaction, called an addition polymerization reaction, because we're adding things together, this double bond is going to open up and it's going to link into somewhere there, and it's going to grab onto this carbon. So, first of all, the first thing that we notice is that this molecule, or one of these molecules, will need to be swapped around. So, it might need to be swapped around so that this carbon, this carbon's arm can reach out and grab onto this carbon. Okay, so that's the first thing that we need to notice. The next thing that we need to notice is that when this carbon opens up, the arm is going to either show up this way, or what we need to do when we write it down to simplify it is we want these 2 arms to show sideways. So if these 2 show, if this arm opens up and it shows that way, and this arm opens up and it shows this way, it means that this little unit on this side is somewhere in the way, because the arm needs to go this way. Okay, so what we do, so first of all, we're going to just quickly swap these around. Okay, so we've got that one sorted, and then what we need to do is we need to open up the arms. So this carbon will have an arm that opens up this way, and this carbon might have an arm opening up that way, but we want it going that way, so we'll do something about that. This carbon has an arm going sideways, and this carbon has an arm going up, but we want it going sideways. So we want to try and get these 2 arms facing sideways and move whatever is in the way. So you can see this carbon and that carbon's in the way, out of the way, so that these arms can open up. So the easy way to do it is, because they have single bonds, they can rotate and they can move wherever they want in space. So let's just move them down like that and open up this arm to go sideways. The same goes, so these 2 are starting to hold hands, this carbon, and then instead of this carbon going that way, it might point down or up, it doesn't matter, and then the arm goes sideways, ready to bond to another molecule. Okay, so what we have here is a whole chain that is written in one long line, instead of going up and down, whatever we need to do. So the secret behind it is identifying what groups are in the way, or identify the carbons that are involved, first of all, and then opening the arms sideways, and whatever is in the way, like this one was in the way, it needs to either flip up or down. So it could look like this, flipping up, or it could look like that, flipping down. Okay, so of course the carbons will be written the same way. So this at the end is going to look like this. And then we have a bond. We'll put this communal bond in black. So we could go down and we'll have another communal bond on that side because it's going to bond to another monomer if we need it. And that one opens up and it's also ready to attach to another carbon. So we want to try and get these carbons all lined up so it's easy to draw instead of having to, if it was this way around, this one, there might be another group linking in on there like that. So it might look a bit like wonky when we have to draw it. So instead of like trying to confusing yourself, we're going to try and simplify it. And the way that we simplify it is we just open up each of these carbons to the side so that this arm opens up sideways and that one opens up that way, and whatever is in the way then just gets flipped up or down. Okay, so whatever they put in front of this, they are gonna might want to trick you and put like chlorides or alcohols or whatever fancy groups they put in there shouldn't be scaring you, or like it might look intimidating because it's a big molecule. But at the end of the day, all we do is whatever they give you, you're just going to flip it up or down and let the two carbons that we are focusing on, the two carbons on opposite sides of the double bond, have them open up sideways and then linking the chains sideways to each other. So hopefully that kind of makes a little bit more sense. It takes a little bit of time to practice and perfect your polymer writing or drawing skills, but I'm pretty sure you guys will be onto it. Cool, see you later. Chemistry, baby, you and me.